You know that feeling when you completely fall down a YouTube rabbit hole? You're just sitting there wondering how on earth the platform magically knows exactly what you want to watch next. Or, how the Google Play Store suddenly surfaces this one perfect app you didn't even realize you needed. It really feels like magic, right? Well, spoiler alert, it's not magic. It's machine learning.
Welcome to this explainer. Today, we're going to completely lift the hood on what everyone vaguely refers to as the algorithm. We're going to demystify exactly how these massive, world-changing recommendation systems actually operate, literally from your very first click all the way to the final suggestion on your screen. But before we get into the weeds, we really need to grasp the sheer scale and impact of this tech. I mean, consider this staggering stat. A massive 60% of all YouTube watch time is driven entirely by their recommendation system. 60%. And over on Google Play, 40% of all app installs come straight from recommendations. So these systems aren't just some tiny, cute feature. They are the absolute core engine driving user behavior across billions of devices. And, they're occasionally the reason you stay up until 3 a.m. watching competitive woodworking.
So, how do they do it? Let's break this massive process down into a logical roadmap. We're going to cover 1. Terminology, 2. The funnel, 3. Candidate generation, 4. Scoring, 5. Re-ranking, and 6. A quick summary.
Okay, Section 1. Terminology.
Let's kick things off by defining a couple of essential terms we're going to need for this journey. The first two are pretty straightforward. Items are simply the entities the system wants to recommend to you, so the YouTube videos, the apps, or the store products. The query, on the other hand, well, that's you. More specifically, it's your information and your current context. This is the whole shebang, your watch history, the search terms you literally just typed in, the time of day, even the specific device you're holding right now. The ultimate goal of the system is to perfectly match a query to the absolute best possible items.
Now, how exactly do we match them? We do it through something called embeddings. I want you to think of an embedding as this massive, multi-dimensional physical room, or like a giant map. The system takes all these discrete things, a user, a video, an app, and physically places them into this shared vector space. The system literally measures the distance between your query and the items using math formulas, stuff like dot product or cosine similarity. But look, all you really need to know is this. If your query coordinate ends up right next to an item coordinate on this map, boom, you've got a match.
Section 2. The funnel. Let's look at the system architecture.
What you're seeing here is the journey of a single query. Because, it's not just one giant brain making all the decisions at once. It's a highly structured, 3-stage funnel. Stage 1 is candidate generation, where we start with literally billions of items and quickly filter them down to a few hundred or maybe 1,000. Stage 2 is scoring, where we take those thousands of candidates and carefully rank them to find the absolute best 10 or 20. And finally, Stage 3 is re-ranking, where we give everything a final polish before the items actually hit your screen. Let's zoom in on each of these.
Section 3. Candidate generation. This is where we narrow the pool.
So when you open an app, the system instantly faces billions of options, and it has to narrow that down in mere milliseconds. There are two main ways it pulls this off. First up is content-based filtering. This one's fairly simple. It relies on item similarity. Say you just watched 2 adorable cat videos. The system goes, okay, great, let's find more videos with the cute animal feature and push those. It leans heavily on knowing the specific features of the items themselves. But then there's the second method, which is way more powerful, collaborative filtering. This one looks at similarities between users. It basically says, hey, user A and user B have really similar tastes. User B absolutely loved this super obscure documentary. Let's recommend it to user A even if user A has literally never shown any interest in that topic before. Honestly, this is where you get those serendipitous, mind-blowing discoveries that feel like total magic.
To make this collaborative filtering actually work, the system builds this giant feedback matrix that maps users against items. You can see it here. A 1 might represent explicit feedback like a glowing 5-star rating, or implicit feedback like you just watching a movie all the way to the credits. By looking at the patterns of 1s and 0s in this giant grid, the math actually discovers which users are similar and which items are similar, and then it ultimately places them close together in that shared embedding space we talked about earlier.
Now, the actual math technique used to pull those user and item embeddings out of that grid is called matrix factorization. It's incredibly efficient, but it's got a pretty massive flaw, the cold start problem. Since the math totally relies on past interactions, what happens when a brand new video drops or a brand new user signs up? Matrix factorization completely falls apart here. because the new item has 0 interactions. To the math, it's basically invisible. It's like a ghost in the machine.
So to solve this cold start problem and make recommendations vastly more relevant, modern systems get a huge upgrade to deep neural networks, or DNNs. And what makes a DNN so awesome is its flexibility. Instead of just relying on past clicks, you can feed a DNN what we call side features. You can feed it the user's age, their country, the exact time since they last watched a video, the language they speak, all of it. You can even run a two-tower model. This is where one neural network learns absolutely everything about the query, a completely separate neural network learns everything about the item, and then the system just finds the perfect mathematical match between the two towers. But training these neural networks, it is intense. One really popular method is softmax training. This basically turns the entire corpus of items into a giant multiple-choice question, calculating the precise probability that you are going to interact with one specific item. However, there's a really fascinating pitfall here called folding. If a system only trains on the things people liked, the embeddings for completely unrelated categories, like, say, Spanish cooking videos and Japanese anime, might accidentally get folded into the exact same physical space on our map. To stop this from happening, developers use something called negative sampling. They actively feed the model completely irrelevant items and basically say, look, this is a bad match. Push these items far, far away from each other. This is absolutely crucial for keeping the embedding space neatly organized.
Section 4. Scoring. It's time to rank the candidates.
Okay, so our candidate generator has done its job. We've gone from billions of items down to maybe 1,000 really solid candidates. But, you might be wondering, wait a second, the candidate generator's already assigned mathematical distances to find these things. Why not just use those exact numbers to rank them? Well, it's a great question. The reality is that a massive system uses multiple candidate generators all at the exact same time. One might be pulling popular local videos, another is using a social graph, and another is running a deep neural network. Their internal math just isn't comparable. So by creating a separate, dedicated scoring model, we level the playing field. And because this scorer is only looking at 1,000 items instead of billions, it can afford to use incredibly complex, heavy context features to figure out the absolute best fit.
And scoring is a really delicate art. I mean, machine learning is kind of like a mischievous genie. It is going to give you exactly what you ask for. If your objective function tells the model to maximize clicks, well, the model quickly figures out that outrageous, misleading thumbnails get clicked the most. The result? You end up with a platform absolutely flooded with awful clickbait. But if you just tweak that objective function to maximize session watch time, the whole game shifts. The model learns to promote high-quality, engaging content that keeps people genuinely hooked for longer periods. The specific math you choose literally dictates the entire culture of the platform.
Section 5. Re-ranking. Time for the final polish.
So, we've scored our candidates. We have our absolute best videos ready to go. But we aren't quite done yet. This is the stage where we apply real-world constraints before the items actually make it to your screen. First up, we ensure freshness. We might artificially bump up the score of brand new videos so the platform doesn't feel stale. Second, we enforce diversity. If the scorer's top 10 list happens to be entirely videos of cute owls, well, you're going to get bored. Re-ranking breaks that up by forcing different genres into the mix. Third is fairness. We actively monitor the outputs so the model doesn't just get stuck looping on skewed data points. And finally, positional bias. We know for a fact that humans click the top result way more than the bottom result just because it's at the top. So the re-ranker actually adjusts the final scores to account for where the item will physically sit on your screen.
Section 6. Summary. Let's put it all together.
And there it is. We've successfully navigated the entire recommendation pipeline. The really crucial takeaway here is how all of these incredibly complex math and machine learning concepts come together in literally a fraction of a single second. Every single time you open an app, your unique query drops into the funnel. The candidate generation stage instantly filters billions of items down to thousands using those embeddings and neural networks. Then, the scoring stage intensely analyzes those thousands with heavy context features to find the absolute best matches. And finally, the re-ranking stage steps in to apply those human-centric constraints like diversity and freshness.
It is just a beautifully engineered system of funnels and filters, relying on multidimensional math to actively curate the digital world right around your specific tastes. So, now that you deeply understand the three-step architecture operating behind the scenes, you can probably look at your own homepages a little differently. What invisible features, user similarities, and objective functions are actively shaping your very next digital experience? Thanks so much for joining me on this explainer. Keep learning, and I'll catch you on the next one.